Um, so this was our definition of derivative that we were working with. And what the heck is a derivative? Slope of a tangent line. Which means we made what? Tangent lines. All right, that's what we did. All right, and we're going to work on that again today. But we make a tangent line. But what do you need for a tangent line? A what? A slope and a point. All right, a slope and a point. That's what we need. All right, so this is what's called an alternate form of a derivative. Okay, and honestly, it's actually been coming up on the AP exam more than I thought it would. So this is what the alternate form is. So f prime is equal to your limit as x approaches some number of f of x minus f of c, wherever that number is going, over x minus c. That is the alternate form of a derivative. It has come up. You have to recognize that that is doing a derivative, but really, this is the one that we need to focus on. This will definitely be on your AP exam. This might be, and honestly, it's been popping up more so than I thought it would be. All right? All right, cool. All right, here we go. Let's keep moving. So we have this greatest integer function. We've kind of talked about this greatest integer function a little bit. And I want to talk about what's going on with this thing. Is this greatest integer function continuous? No. Why not? Why is this greatest integer function not continuous? What's happening on it? Jump discontinuities, exactly. All right. And so what we're going to do is we're going to use the alternate form of the derivative at 0. Okay, so we're going to go from the left, we're going to go from the right. And so when we do that, we have a limit as x approaches 0 from the left of our greatest integer of x minus 0 over x. So if I do it from a little bit from the left of 0, what's my greatest integer from the left of 0? It's my greatest integer, guys. No. -1. It hadn't gotten to 0 yet. So my greatest integer is still what? -1. And then I have minus 0 over a really small what? Negative. A really small negative. So I have a -1 minus 0 over a really small negative. What does that make it? Positive infinity. Makes it positive infinity. Now let's do it from the right. So now I have a greatest integer of 0 from the right. So what is that? 0. It's 0. So now I have 0 minus 0 over 0 from the right, which is a really small what? Positive. So I have 0 over a really small positive, which makes it what? Zero. 0 divided by any number is 0. So it makes it 0. Now, is my derivative on my alternate form the same? Is it the same? No. So it's not continuous. We already talked about that. And this function is also not differentiable. Okay? Because my derivatives were not the same. All right? So guess what? If it's not continuous, it is not differentiable. All right? Always. All right? If it's not continuous, it's not differentiable there. All right? All right, let's keep moving. Here we go. Let's do another one. So now we have an absolute value function. And I never do calculus with absolute values. I really don't. If you want, the notes are right there for the calculus part. I don't care about the calculus part on absolute values. Because what do we know about an absolute value? If it's an absolute value, x minus 2, we know it's shifted 2 to the right, correct? And then what's my slopes here? What are my slopes here? 1 and -1. All right? You know that without doing anything. All right? You already understand what the heck an absolute value graph does. All right? So if I take a limit of an alternate form of a derivative, a slope of my left. What is my derivative from the left of 2? -1. What is my derivative from the right of 2? +1. Now, is this function continuous? Yes. But is it differentiable at 2?
No.
No, because it makes a sharp turn. All right? So if it makes a sharp turn, it doesn't have the same derivative from the left and the right. It's not differentiable, even if it is continuous there. All right? So does continuity always mean differentiable? No. Okay? And the one reason that we have right now is it's a sharp turn. Okay? You can't be a differentiable at a sharp turn. All right, let's look at this one. So now I have f of x is equal to x to the 1/3 power. And this one we honestly need our alternate form. First of all, is this function continuous?
Yes.
Yeah, sure is. All right. I can draw without lifting my pencil. My limit is equal to my value everywhere. So now I'm going to use the alternate form of this derivative. So if I substitute in, I end up getting this x to the 1/3 minus 0 over x, as the limit as x approaches 0. Well, what does this simplify to? X to the 1/3 over x. What does that simplify to? Good. That's exactly it. All right. You know how to subtract. So 1 over x to the 2/3. That's good. All right. We learned something in Algebra 1 and Algebra 2 and Pre-Calc. All right. And so now if I substitute in 0, what do we get? We get a number of 0. True. So if I go a little bit from the left or a little bit from the right, it doesn't matter here because I'm going to square it and then cube root it. So what would it be? A positive number over a really small what? Positive, which makes it positive infinity. What does that mean? If I have a derivative that is positive infinity, what does that mean? It means it's going straight up right there. All right? It means its slope is undefined. It means it has a vertical tangent. Are you allowed to have a vertical line as a tangent? No, you're not. All right? You can't have that. It has to be some type of number. All right? Infinity's a direction. It's going straight up. So this is a continuous function. However, this is also not differentiable because we have a vertical tangent line. All right? Now, I want to talk about if the function is differentiable. If the function is differentiable, that means it will be a smooth curve all throughout. If I have a smooth curve all throughout, it is differentiable, which means, will this function be continuous as well?
Yes.
Yes. So, if the function's differentiable, will it be continuous? Yes. If the function is continuous, does that mean it's differentiable? No. What two things tell me that it won't be differentiable? Sharp turn and a vertical tangent. Okay? If it's not continuous, will it be differentiable? No. Okay? So, those are the things that we need here. All right? All right. Please write these down, and then I'd like you to get to number 39. Here we go. 39. Can somebody read the directions for us? Sarah, you got them up?
No.
Danny, you got it up?
Okay, I have it.
Oh, go ahead.
The graph of f is given, select the graph of f prime.
All right. So we're going to do the graph from f, and then we're going to make f prime's graph. Okay? What's an f prime? It is a what? A derivative. And a derivative is a tangent, a slope of a tangent. All right? So what we're doing is we're taking our regular f graph and we're going to make its slope graph. Is everybody hearing me? All right, here we go. Here we go. So I want to talk about what's the slope here at like -3? 1. All right, let's go with 1. What's the slope here? 1. I'll go with that. How about here? What's the slope there? What's the slope? 1. I'll go with that. Love it. How about here? 1. How about here? How about everywhere? 1. Everywhere, my slope is 1. So that is my f prime graph. Because my slopes of f is 1 everywhere. So there's my y equals 1. There's my f prime graph. See how that worked? All right, let's do it again. So let's look at 40. So what is my slope, like right there? What do we think that slope is? You see how it's kind of going with that curve? What do you think my slope is there?
-10.
-10? All right, so that's that big of a negative. Okay, all right. Is everybody cool with -10?
Sure.
That seems super slopey to me, but -10 sounds good down there. Perfect. Okay. All right. How about right here? What's my slope right there?
-8.
Okay, sure. All right. How about here? You guys good with that? All right, at least we're getting less slopey, sure. All right, how about right here? 0. It is horizontal right there, exactly, good. Now, what about right there? 2, okay. How about right here? 8. All right, so we're going to connect them. So there is my f prime. All right. Now, I'm not extremely specific on what they are, but this right here would be negative. This would be less negative. Does everybody agree? And then this would be a little less negative. Agreed? And then that's 0. And then what's it start doing? It gets positive. And then what? More positive. And then what? More positive. All right? And so that's what I want you to see from those. All right, go some more. So here we go on 41. What is my slope right here?
It's going to be pretty big.
It's going to be pretty big, like that. Pretty big, pretty steep, right? So what do we say it is?
Let's go with 5. That's on the
5? All right, let's go with 5. So right there we got 5. How about right here?
2.
I would definitely not go with 2 yet.
3.
Right here. Rise over run. I do not see that thing going at like 3. Because this right here would be 1. Agreed?
Yeah.
So this would be like less than 1. True?
So 0.5.
So half 1, something like that. I can't go with 3. I can't do that. All right. I can go with a lot, but all right. How about this one? What's my slope there? Is it more or less than what we just did? Less. But is it still positive? Yes, it is still positive, but it is less than what we just did. How about right here? Is it more or less than the one we just did? It's less, but is it still positive? Is it ever going to be negative here? No. So when we connect them, our slope graph looks like that. So that is what f prime is. See how we did that? All right, let's do this one. On 42. What is my slope over here? -1? Sounds good. How about right here? What's my slope there?
-1.
-1. How about right here? How about right here?
0.
How about right there on that sharp turn? There is no slope. Why is there no slope? Because it's a sharp turn. All right? But everywhere to the left of 0 is what? -1. All right. How about right here? What's my slope there? +1. How about right here? +1. How about right here? Good. So everywhere to the right of 0 is what? +1. So that is my f prime graph. See how that worked? Because what's a derivative? A slope of a tangent line. All right? So I want you to start thinking about not just the function, but I want you to think of the derivative of that function. All right? All right. Let's see.